Here's a tutorial for stoichiometry with nuts and bolts. So for the example, I've already made a reaction. 5 nuts, 7 bolts, 3 washers makes 3 nuts, 4 bolts, and a washer. And it also makes 2 nuts, 3 bolts, and 2 washers. So this all balances between here. Here's the arrow, here's the dividing line. Everything that appears on the left also appears on the right, but of course, rearranged. Now, I really did this and weighed the nuts, bolts, and washers, and this is the grams per each individual one. So you can just have that information. So here's the visualization that's represented here. When you go and make your own reaction later on, then you will assemble this physically here, and that's when you get the stamp there, which of course you don't get on this one, because you have assembled this physically there and show me. In this case, I provided the picture, so of course there's no stamp provided if the picture is already provided. On step 4, what we're going to do is find the mass mathematically of the products. So in product 1 here, there are 3 nuts. There are 3 nuts at 3.2 grams. So that's this total. There are 4 bolts at 6.5 grams each. So that's this total. And there is 1 washer at 2.2 grams each. So then this plus that makes that. Then we're going to go do it for this product also, which is here. And we get these 3 totals and we add them up to get that. Then you get to make a choice. Which product would you like to start? Which reactant would you? Then you get to make a choice. Which reactant would you like to start with? You can choose 5N, or honestly, you could choose some multiple. You could do 10N or 15N. It gets a little bit more complicated, but you can. I choose 5N. You don't have to choose the one on the left. We could choose the one in the middle, but I choose 5N to start with. Now, just mathematically, what's going to be the mass of the product? This says if you put in 5, you get out 1, and you get out 1. So which product do you want to choose? I choose, which one did I choose? I chose that one. So we're going to start here and go to there. You could start here and go to there, though. Just choose something. But in my example, I'm going from here to there. For every 5, you get 1. I'm going to choose to start with 5. That's fine. Just don't start with 6 or something. If you're going to choose something else, choose a multiple of 5. And 5 is fine. You can just choose that number right there. I choose 5N. Fine. 5 will get you 1. So the ratio is 5 to 1. The N goes down here so that it cancels out. And if you put in 5, you'll get out 1. Obviously, you'll get 1 set of that. What's the mass of 1 set of that? Well, we found it back up here. It's 37.8 grams for every set. And how many sets did you have? 1 set. This figure here, this fraction comes from here. It's 37.8 grams for every 1 set. How many sets do you have? I have 1 set. Okay. This cancels out. 1 set, 1 set. And we get 37.8 grams should be the mathematical calculation of the mass of that. And then we're going to actually take them. We're going to take this is the product we were talking about, and put it on the scale. And we got 37.92. Look how close that is to what we calculated. Reality has been predicted by the math. The math is not just something we're doing. It actually works with reality if you do it right. So the actual mass was, well, I made up this number, but 37.92, sure. And on 8, do the calculations predict the mass of the product? Yes, they do accurately predict the actual mass of the product. Here I'm going to make my own version. So I said 2 bolts plus 3 nuts plus 2 washers makes a bolt and 2 nuts, and a bolt, nut, 2 washers. So I wrote it out here. I got it balanced, and actually I had made a mistake. Double checking led me to my mistake. I have now physically assembled it, which is step 3, and I get a stamp for proving that I know how to physically assemble what I've written down and that everything balances left side, right side in both cases. So let's find the mass of this product. There's one bolt at this grams, two nuts at that mass, and the total then between this and that is that added up. And we do the same for the second line. So just to change things up, I chose 4 washers as my input, my reactant input. Now I know that says 2, but my point previously was you can choose 2 or 4, 6, 8, 10, a multiple of one of these numbers. It's fine. And in real life, you can do fractions, but here's we can't because we can't have a fractional bolt or a fractional washer or something. So we're going to use whole multiples, and I have chosen 4 washers for the reactant and chosen to go to that product. So I put in 4 washers. I know that 2 will get me 1, so I'm going to put the washers on the bottom so they cancel out. The ratio is 2 to 1. If you're going to put in 4 instead of 2, you're going to get 2. If you put in 20, you're going to get 10. If you put in 200, you're going to get 100. It's half as much. If you put in 18, you're going to get 9 because you're going to be multiplying by 1 over 2. And so you're going to get half of what you put in. This time I'm going to get 2 sets of the product, and I know each one of them is 14.1 grams for each one set. How many sets am I going to make? 2. So I'm going to have double of that because I'm going to use 2 sets. And I calculate it should be 28.2 grams. I'm going to take the actual thing, and it is 28.3 grams. 28.3 grams. And yes, the calculations predict the real mass very closely, as a matter of fact.